Hello friend, myself Sanjeev Dwivedi and on behalf of Vidyalankar Institute of Technology, I welcome you all in this conceptual video session for the subject Advanced Algorithm. In this video, we'll be talking about probabilistic analysis of an algorithm. Now, when it comes to probabilistic analysis of algorithm, it uses the probability for analysis of algorithm, correct? So this particular approach will involve probability angle to analyze our particular algorithm, and we will understand this with a standard example of hiring problem. Now, what is this hiring problem? It is a case study. This is the example that we need to consider in your syllabus. Let's say an office needs to hire an assistant. Now for this, the office contacts an agency, correct? The strategy goes like this. The strategy goes like this, correct? It says agency will send one candidate every single day. Now इफ द न्यू कैंडिडेट, नाउ कंपनी क्या बोलेगी, अगर ये जो नया कैंडिडेट है वो बेटर देन है पुराने से, तो वो क्या करेगा, फायर करेगा और नया कैंडिडेट हायर करेगा. Now when it comes to firing the earlier assistant or hired person, the company has to give some money to that particular person. So obviously there is an angle कि whenever there is an hiring done, the candidate has the company has to pay extra money. See, if the new candidate is better than current assistant, then I means the organization has to fire the current assistant and hire the new candidate by paying the fee. Now let us see an algorithm that can be used to best represent this. Okay, it is simple approach, but there is some flaw. Let us talk about the approach. Let's say there will be an n candidate sent, correct? Initially best is some dummy candidate initialized to 0, correct? So this is best with value 0. Now for all candidate 1 to n, if the next candidate I is better than the best is initially 0. So if the next candidate I will be 1 to n is better than the best, then best will be new I and we will hire the candidate I. Now remember one thing, here the time is not a constraint but cost is the constraint. So when it comes to analyzing this particular algorithm, हमारा अप्रोच होना चाहिए कि कॉस्ट कम से कम होना चाहिए, ठीक है. नाउ लेट्स सी हाउ टू डू दैट. पहले हम अप्रोच देखेंगे. नाउ लेट्स सी दैट लेट अस associate some cost with each activity, ठीक है. So let us say CI be the cost of interviewing a candidate. So it is a low cost activity. So when I'm just interviewing a candidate, it is a very low cost, that it is only the cost that I have to pay for interviewing to the agency. It is the cost of interviewing the candidate. Now suppose I'm hiring, let the cost be CH, correct? CH is the cost of hiring a candidate and it is quite expensive. Why? Because we have to pay some money to the current one. At the same time, we have to pay additional money to the agency if I'm hiring a new candidate. So let us talk about the total cost in totality. ठीक है. Now let we interviewed n candidate. Cost of interviewing each candidate is CI. So I am going to interview candidate. So it is NCI, the total cost of interviewing a candidate. Let the cost of hiring each candidate is CH. So then let us say there will be M candidate hired out of N. So out of N interviewed, we hired M candidate. So let there be MCH. ठीक है. So this is my total cost. I'm going to interview N. Cost of every interview candidate is CI. So there will be NCI plus there will be M candidate hired and the cost associated is CH. So MCH. So this is my total cost. Now, okay. अब हम इसका वर्स्ट केस क्या हो सकता है. हम वर्स्ट केस में ऐसा कह सकते हैं कि जो एजेंसीज हमको भेज रहे हैं कैंडिडेट, वो इंक्रीजिंग ऑर्डर ऑफ क्वालिटी में भेज रहे हैं. इंक्रीजिंग ऑर्डर ऑफ क्वालिटी मतलब कैंडिडेट 1 मैंने हायर किया, कैंडिडेट 2 इज बेटर देन कैंडिडेट 1. सो मैं कैंडिडेट 1 को फायर करूंगा, कैंडिडेट 2 को हायर करूंगा. कैंडिडेट 3 इज बेटर देन कैंडिडेट 2. सो मैं कैंडिडेट 2 को फायर करूंगा, कैंडिडेट 3 को हायर करूंगा. नाउ अगर आप इसमें देखेंगे, यानी जितने n कैंडिडेट आ रहे हैं इंटरव्यू के लिए, सबके सब हायर हो रहे हैं. तो इसके हिसाब से मेरा जो हायरिंग कॉस्ट हो जाएगा वो NCH हो जाएगा. इधर मेरा हायरिंग कॉस्ट क्या था, MCH. भाई n में से हमने m हायर किया था. So if candidates are in increasing order of quality, then we hire every next candidate and then we hire total how many candidate beta? We hire total n candidate. Because we don't have C. Now why this could be the worst case? This could be the worst case. Now, why this happens so? Because we have no control over in which the candidates are sent to us. Now, यहाँ पे probabilistic analysis will play important role. With probabilistic analysis, control the order, and thus we can improve the cost. So we can see this one particular case study, and now we are going to look about how the probabilistic analysis will play important role and can bring down the overall cost. Let us see. Now what is probabilistic analysis? Everyone, please be with me. Probabilistic analysis for randomized algorithm. Now what happens here is, here we use knowledge of data and make certain assumptions, correct? We will have some information and we'll make certain assumption on distribution of data, or we can also say distribution of input. Now let's see how we're going to introduce this to our hiring problem. Now what we say, we analyze and compute average cost running time. हम क्या कंप्यूट करेंगे? एवरेज कॉस्ट रनिंग टाइम. नाउ वो हम कैसे करेंगे हायरिंग प्रॉब्लम में? लेट अस सी. ही लेट अस असाइन रैंक टू ईच कैंडिडेट. करेक्ट है? तो हर कैंडिडेट का रैंक क्या होगा? रैंक ऑफ आई. सो कैंडिडेट 1 रैंक 1, कैंडिडेट 2 रैंक ऑफ 2. रैंक ऑफ 2 विल गिव मी रैंक ऑफ सेकंड कैंडिडेट. नाउ let us assume that here we assume that the candidate appear in random order. So the rank will form uniform random permutation because the candidates are coming in random manner. So कितने permutation possible है? Candidate random order में आ रहे हैं. We can have n factorial permutations. क्यों? Because हमारे पास n candidate हैं and the permutation of appearing them with equal probability. Now let us see the problem with this. Now problem ये है कि जैसे हमने कहा कि सपोज एजेंसी इज सेंडिंग द कैंडिडेट इन इंक्रीजिंग ऑर्डर टू मेक मनी. सो अब जैसे हमने एग्जांपल में देखा, सो हम क्या करेंगे? हमको ऑर्डर कंट्रोल करना है. सो वी विल कंट्रोल द ऑर्डर बाय चेंजिंग द मॉडल. कैसे मॉडल हम चेंज करेंगे? एक तरीका क्या है? वी टेक लिस्ट फ्रॉम द एजेंसी. हम एजेंसी बोलेंगे तुम लिस्ट दे दो मुझे, एंड देन वी विल अरेंज द सीक्वेंस ऑफ द कैंडिडेट इन रैंडम मैनर. ठीक है? So what is randomized happen here? Algorithm is randomized in behavior. See, when we can say an algorithm is randomized in behavior, it is randomized in behavior if the input is produced by random generator. See, आपने क्विकसॉर्ट पढ़ा, आपने क्विकसॉर्ट का वर्स्ट केस क्या देखा था? आपने क्विकसॉर्ट का वर्स्ट केस देखा था जब मेरा एरे ऑलरेडी सॉर्टेड है, इंक्रीजिंग ऑर्डर और डिक्रीजिंग ऑर्डर. ना वहां पे क्या होता है? आफ्टर एवरी, ठीक है, आफ्टर एवरी आइटरेशन माय एरे वाज नॉट गेटिंग डिवाइडेड इनटू हाफ. इट वाज गेटिंग डिवाइडेड इनटू 1 n-1 देन 2 n-2. ना हम उसको इंप्रूव करने के लिए रैंडमाइज कर सकते हैं. हम क्या कर सकते हैं? हम फर्स्ट एलिमेंट को किसी भी रैंडम पोजीशन से स्वैप कर देंगे. अब जब हम क्विकसॉर्ट अप्लाई करेंगे, even though it will go back to our older position, but then will cause my array to divide into 2 half. Correct? So that will bring down my running time. So let us see how randomization here will play important role. Now here for this we are going to introduce you a new concept called as indicator random variable. Now what is indicator random variable? It is a method to convert between probabilities and expectation. Now what do you mean by that? Let's say A is any event. Correct? So indicator random variable on event A will be represented as I bracket A. Now indicator random variable can take only two values, 1 or 0. So I of A will be 1 if the event A occurs, and I of A will be 0 if the event A does not occur. Now let us take an example in terms of coin toss. Let x of h be an indicator of head. So let us see, I want head and I want indicators. So I want to represent any indicator for head. So let the x of h be an indicator on head. So indicator on head will have value 1 if head appears, see if h, and will have value 0 if tail appears. Correct? So this is my x of h is indicator of head. So let us find expected number of head in one flip. So if I am flipping the coin once, one flip, then I want to find, correct, so what is expected number of head that can happen. So it is IH, indicator random variable for head. I am going to apply expectation on it. So expectation on indicator random variable for head is 1. 1 why? Because if it is head, then indicator random variable will take value 1. 1 into what is probability of head? Half. So it is 1 into half plus 0. Why? Because indicator random variable for tail is 0. Value will be 0. So 0 into what is probability of tail? Half. So probability of head and tail remains the same, half. So when it comes to expectation on number of heads in one flip, it's half. Correct? There is half chance in one flip we can have this kind of expected result. So let us conclude a lemma. Correct? Now what it says, if we are given a set S and any event A, then what we can say that indicator random variable for event A will be represented by IA, and the expectancy, that is how on expectancy of XA, means expectancy on indicator random variable X on event A is E applied on X of A. Now what is E applied on X of A is here we got E applied on X of head is half, means the probability of head. So please try to understand, when I say expectation applied on indicator random variable for head, please be with me. Expectation applied on random variable for head is half. But what is half? Half is probability of head. In the very same manner, now what was head here? Head was the event. So what we can say that expectancy of indicator on any event A is represented by E on X of A, which is nothing but probability of occurrence of that event A. Correct? This is a lemma that we can deduce. Now this was for one flip. E X of H was half for one flip. Let us consider for n flip. So for n flip, it will be summation I equal to 1 to n for all x of I. Correct? So which is expectation on X. So expectation X is what? This summation R sigma I equal to 1 to n X of I. Correct? So this expectation will go in summation. So it is summation I equal to 1 to n. Correct? Expectation on of X of I. But what is expectation on X of I? Here in our case for coin flip, the expectation on X of H is half. So expectation on X of I is half. So it is summation of I equal to 1 to n on half will give me n by 2. So this is on indicator random variable. Okay, so this is some kind of understanding on indicator random variable. And in the next video, we will see how this indicator random variable concept is used for hiring problem and for a birthday paradox. Thank you very much for this session. Thank you.